Hey everybody, welcome to section 11.1 guided practice. This is the guided practice for week 10.3 or section 11.1 in your book. And this particular guided practice deals just with the square root property and maybe a little bit of factoring when it comes to basic quadratic equations. So let's dive right in here. Quadratic equations. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0. Provided a isn't 0, because if a is equal to 0, this term is actually gone, and we're just left with a linear equation. So we refer to this as standard form. So in this first example, we're going to do some solving by factoring, nothing fancy here. The first thing that we want to do is we want to write this in standard form equal to 0. So we want this in the form ax squared plus bx plus c equals 0. And it's not in that form simply because we have this not equal to 0. So let's go ahead and set it equal to 0 by rewriting it so that this is 3x squared plus 5x. And then we'll subtract 2 from the right side, bring it over to the left side. And now we are in standard form. And then it says step 2, factor that sucker if you can, and that might take a little bit of work on your part. We're going to have a 3x and an x, and we got to get close to 5 with the factors of negative 2. So I think with a 2 and a 1, we would get 6x, and then if we minus 1x, we're going to get that 5x in the center. So I think that that's good. It's still equal to 0. So we've factored it. And now we're going to talk about the zero product property. Set each factor equal to 0. Well, the zero product property says if you multiply two things together and it equals 0, then either A is 0 or B is 0 or both. And that's what we have here. We have a product. Instead of adding a bunch of stuff together, we're now multiplying two factors together to get 0. So that says either 3x minus 1 equals 0 or x plus 2 equals 0. And so now what we're going to do is we're going to solve each one of those equations separately. If 3x minus 1 equals 0, then 3x equals 1, meaning x equals 1/3, or if x plus 2 equals 0, then x equals negative 2. And those are our answers. And our solution set is x equals 1/3 and negative 2. Or sometimes you'll see it written as, with squirrely braces, 1/3 and negative 2. Okay. Now, suppose we only have the variable squared term and a constant term. So this is what I was talking about in the lectures, where if we rewrite this, this is x squared plus 0x minus 9 equals 0. And we're talking about having a b value that's equal to 0 here. So what value of x could make this true? Well, now what they're talking about us doing is just simply using the square root property. Since b is equal to 0, use the square root property, which says if x squared is equal to 9, then x is equal to plus or minus the square root of 9, which is plus or minus 3. So our possible values here are positive 3 and negative 3. And then they want us to basically do the same thing again, but generically. This is the square root property stated. If x squared is equal to c, then x is equal to plus or minus the square root of whatever c is. So that's just a general statement of the square root property. So that's actually what we have here and what they're stating. If x squared is equal to c, then x is equal to plus or minus c. Use this property to solve quadratic equations that involve only a squared term and a constant term. That is to say, again, the b value is equal to 0. So isolate the squared quantity. In this equation, the squared quantity is just x squared. 5 isn't squared. 5 is a multiplier on the squared quantity. So 5x squared is equal to 49. or x squared is equal to 49 over 5. And then it says use the square root property to take the square root of both sides. So if we have x squared is equal to 49 over 5, then by taking the square root of both sides, what we end up with is x is equal to, don't forget your plus or minus, the square root of 49 over 5, that fraction. And then it says simplify the radical. X equal to plus or minus the square root of 49 over 5 is plus or minus the square root of 49 over the square root of 5, which is plus or minus 7, because 49 is a perfect square. Not a lot we can do with the square root of 5, but we can rationalize the denominator by multiplying top and bottom by the square root of 5, and this becomes plus or minus 7 root 5 over 5. Now in step 4 they say isolate the variable, but in truth the variable is already isolated. X is just plus or minus 7 root 5 over 5. And then it says write the solution set. All right, well, 7 root 5 over 5 or negative 7 root 5 over 5 is our solution set. By the way, this is perfectly acceptable here, that format. You don't need to do it with the squirrely braces. Okay, let's solve another equation. Here we go. Let's do the same thing. The first thing that we're going to do here is isolate our square. This time our square is p minus 4 squared. So p minus 4 squared is equal to negative 16. We'll then take the square root of both sides, or use the square root property. It says p minus 4 is equal to plus or minus the square root of negative 16. We'll simplify that radical as plus or minus the square root of negative 1 times the square root of 16, which is plus or minus I times 4, or p minus 4 is equal to plus or minus 4i. And then we'll solve for p by adding 4 to both sides, and this tells us that p is equal to 4 plus or minus 4i. Or our solution set is 4 plus 4i, 4 minus 4i. But again, this is perfectly acceptable. And then we talk about Pythagorean theorem here briefly. Pythagorean theorem says in any right triangle, that's a triangle that has 90 degrees in one of its corners here. That's indicated by this little square. The square of the hypotenuse, that's the side, the longest side, which is opposite the right angle. This is the hypotenuse, and this is a leg, and this is a leg. The square of the hypotenuse is equal to the sum of the square of its legs. So a squared plus b squared is equal to c squared. That's the statement of Pythagorean theorem. Okay. So Glenn leans a 20-foot ladder up against a house. So let's see here. Here's our house. It's such a nice little house. Old school. With our one story or two story with a one window up top. And we're leaning this ladder on the side of the house. Well, it turns out that that's going to create a right triangle. So this is the ladder, this is the side of the house. Come on. This is the side of the house. And this is the lawn or the driveway or whatever. And it says the ladder is 20 feet. If the base of the ladder is 4 feet away from the house, how many feet above the ground is the top of the ladder? Well, we can call this a variable, and then we can use Pythagorean theorem that says x squared plus 4 squared, the sum of the square of the legs, is equal to the hypotenuse squared. So this actually is a quadratic equation. In this particular case, it's x squared plus 16 is equal to 400, or x squared is equal to, if we subtract 16 from both sides, 384. So using the square root property, x is plus or minus the square root of 384. And wouldn't we like to know what that is? Let's find out. 384, let's see, 4 goes into that. How many times? 4 goes into 38 9 times with 2 left over, and then 24, it goes in 6 times. So 96 sounds about right. And then that's a perfect square, so we'll just leave that like that. And what about 96? I guess 4 goes into that again. 4 goes into 9 twice with 1 left over, 24. And then 24 is 4 and 6. And so this is equal to plus or minus the square root of 4 times 4 times 4 times 6, which is plus or minus the square root of 4 times the square root of 4 times the square root of 4 times the square root of 6, which is plus or minus 2 times 2 times 2 times root 6, or plus or minus 8 root 6 is how high that is above the ground. Now, if we use a calculator, obviously we're not going to be negative a certain amount of feet above the ground, but the square root of 384 as a decimal is about 19.6 feet above the ground. And so this is about 19.6 feet, not negative 19.6 feet. Hopefully we're not below the ground here in the basement as our ladder falls down or something weird. That's weird. So we would say then that about 19.6 feet in the context of this problem. In our last example here, it says the function s of t equal to 16t squared models the distance s of t in feet that an object falls in t seconds. So we have our plane here and our skydiver. Wow, that does not look like a skydiver. Anyway, that's my skydiver. And what they're saying is the distance that this person falls over time is going to change. And this is the distance he falls after 1 second, and the distance he falls after 2 seconds, and the distance he falls after 3 seconds. So this formula, s of t equals 16t squared, will tell you how far you fall in a certain amount of time. For example, at t equals 4 seconds, s of 4 is 16 times 4 squared, which is 16 times 16, which is 256 feet. So after 4 seconds, the skydiver will be 256 feet below the height when he jumped out of the plane. Okay. Now, it says, a skydiver jumps from an airplane and falls for 3,200 feet before opening his parachute. For how many seconds was the skydiver in free fall? So, the question now is, if he falls for 3,200 feet, how much time has he been in the air? Well, that's not an input-output question. That's an output-input question. So this is a quadratic equation. 3,200 is equal to 16t squared, and we need to solve for t. So we'll divide both sides by 16, and we'll get 200 is equal to t squared, or t is equal to plus or minus the square root of 200, which is equal to plus or minus 10 root 2, which is about 14.14 seconds, plus or minus. Now, in the context of this problem, we're not falling backwards through time, so we're going to ignore the negative. Ignore negative time. And so the skydiver was falling for 14.14 seconds. To travel 3,200 feet, dude. Seems like the plane wasn't up very high, and it was kind of a waste of time to do all that skydiving for 14 seconds. So when you see those long videos that are several minutes long of people skydiving, they got to start up super high in the sky, man. Anyway, the whole point of this is that these word problems, both this one and the previous one, generate quadratic equations that you can use the square root property to solve.